So this is a dilated question. Dilation means it's increasing or decreasing in size. So if you have this equation, the first thing you want to do is you want to write it as y equals mx plus b. So let's write this over here. So you've got 3x minus y is equal to 6. You move the 6 here and the y here and you flip the signs. So what do? You subtract by 6, so you get 3x minus 6, and you move the y so the negative becomes positive. Now you've got mx plus b. The 3 is the m and 6 is the negative, and b is the negative 6. All right, now what's the deal with dilation? When you are multiplying, when you have a scale factor of any number, here it's half, you simply are going to multiply the y-intercept by half. This remains the same. All right, so this becomes 3x minus 6 times half, and that's the answer, 3x minus 3. And so you've got y is equal to 3x minus 3, which makes 4 as your correct choice. Now you try the same problem, but here you, instead of half, you got 1/3. So try that question now. So remember, the first thing you want to do is you take this and you move it around. So you get y is equal to blah 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 x plus another value, and then this value remains the same, and this value is multiplied by 1/3. And so try to find this answer. Y is equal to what? X plus another value is going to be the resulting dilation. Post your answers in the comments and let's move on. This is a super important problem about dilation around a certain point. So let's see how we can do this. So there are two important things. First of all, this line is dilated by a factor of 2. And where is it centered at? It's centered at 3, 5. So I've drawn it over here. So this diagram, I've just clarified it over here. You've got 3, 5. Now the first step is you want to find out, you want to go from here to here like a rise and run style. So you want to go down by 3 units here, and then you go 2 over here. So 3 and 2 this way. So now what do you do? Because this is scale factored by 2, you just take 3 and multiply by 2. So what are you going to do? You're going to go from this original point, which is the center, so to speak, and instead of 3, you're going to go twice that, so it's going to be 6 here, like so. Now remember, the 1 was 2, so now this time, because the scale factor is 2, you multiply it, you double it, you go 4. So 3, 2 became 6, 4. You can even think about this as a triangle. This is a triangle, this is the double triangle. And so, of course, this point over here is your image. So B became B prime over here. So of course the answer over here is 7 comma negative 1. Obviously 7 comma negative 1 is the only one answer over here, so this is correct. But let's try to find the value of A. So how do we do this now? So to find the value of A, again, you start from this center point, then you go down 1 because that's your rise, and then how many is this across? This is 3 and 3, so it's 6 across. So 1 down and 6 to the left. Now you want to double it again because the scale factor is 2. So what do? You will go down 2, right? Always start from this center. You go down 2, and then how much are you going to go? Twice of this 6. So this is 6, and then another 6 here. That makes it 12. So this length is 12. And so you arrive at this point over here, which is of course negative 9 comma 3, and this ties with this value. So clearly this is the answer. Now you try this problem, but instead of going by 2, you want to go down by 4. So scale factor of 4 around 3 comma 5. So see if you can get this answer. Post your answer in the comments. This will really help you understand this idea of dilation of the straight line. So in this sequence of rigid motions, there is a certain way you want to approach them. The first thing is you want to check if there is any reflection at all. If there's no reflection, then you want to check for rotation. And if there's, of course, after this is done, there is most probably going to be some kind of a translation. So these are the 3 parts that you always want to check. So I moved these over here, and now let's actually try to see how you can adjust. So is there any reflection? Reflection means it's going to flip around. It's going to look something like this. This part doesn't look like it. It just looks like this triangle is what you want to pay attention to. This triangle actually became this way. So it's kind of like moved. It was standing in a way, and now it's lying down. So how much is it moved by? It's moved by 90 degrees. What I'm trying to say is this triangle and this angle are the same, only they've kind of like, it's standing and it's now sleeping. So this angle is 90 degrees. So but though you also want to know how this goes. So you got this over here, and when you move it by 90 degrees over this point, you're going to have it over here. This point and this angle is going to go up here, and then you've got this line which goes over here. Do you see what I'm saying? This point goes over here. Also, another way to think about it is if you have this length is 5, this length is -1 comma 5, then you know it's going to go to this quadrant, but you just flip the coordinates. So of course when you flip it, you get 5 and 1, and just be mindful of the signs. The same way all of these other points will work. So this is the first step. Now from here, how do you go over here? Of course you want to think about it like this. You're going down by 4 units and 1 across. So -4 comma 1. -4 comma 1 is your vector, or how it's going to move. So of course the answer is, first it's rotated by 90 degrees. Now is it clockwise or counterclockwise? It's going in this direction, so it's clockwise. And then after that it's translated down by 4 units, and then to the right by 1 unit. And this is your answer to this problem. There are multiple answers, but this is one answer to this problem. Now here's my question for you. If you have this one and you want to move this part over here, how will you translate it? Remember, you always want to, how will you do the rigid motions on it? Remember, you always want to check for reflection. Does this look like this is a reflection? If it is, then you just want to think about what the reflection would be. Is it over the x-axis or the y-axis? And then do the translation. In other words, how much is it going to the left and how much is it going down? And post your answers in the comments, and I'll move on to the next question. This is a very easy but important problem to understand. What you're told is this triangle ABC over here is dilated or shrunk to this smaller triangle, and they're asking you what's the scale factor. So this is very easy. All you need to do is understand what is this length. So this length over here is 1, 2, and 3. So this is 3 units, right? Now this length over here, this corresponding length, this length became this length. So it became only 1. So 3 became 1. So how do you write it? You're going to write down this final length, which is 1, and you divide it by the initial length, which is 3. And that's the scale factor. So the scale factor is simply 1/3 in this question. Now my question for you is, if this is 1/3, this is 1 and this is 3, and this part is 3 already, then can you guess what is this length here? Remember, 1 became 3, so 3 became how much? That's my question for you. So post your answer in the comments. So you've got this square over here, and they're saying they're going to transform it in various ways and it should remain the same. That's what they're saying. It's onto itself means it should remain the same. So let's look at the first choice itself, reflection over the y-axis. So you've got the y-axis here, and how do you reflect it? So let's take a look at each point here. This point, when you reflect it, what does it mean? You want to go through and come over here. Imagine this is a mirror, and it should be very symmetric. In other words, what's on the left goes to the right. That's all. What's on the left goes to the right. So this is on the left, goes here. Now what's to the right is going to go to the left the same way. How much is it to the right? It's 3. So here it's going to go left 3, because it went right 3, it's going to go left 3 over here. And so this point is the new reflection of this point. The same way, this point here is 1 unit to the left of the y-axis, right? So this point actually moves to the right by 1 unit, and this one is 3 units to the right. So this point actually moves over here to the left by 3 units. So you see this square, these 4 points actually came here. Let's just connect them real quick. It's gonna look like this. This is another square, but still it's not the same and the same position as this original one. And so therefore this reflection over the y-axis does not carry the square onto itself. It changes the position of it. And so therefore this is the correct answer. Now my question for you is, what happens to this point? Remember, this point is 3 comma 2. What happens to this point when it's reflected over the y-axis, over the x-axis, my bad, over the x-axis? So remember, if it's up, it's going to go down. So my question for you is, what are the coordinates of this point when it's reflected over the x-axis? So it's going to be in this vicinity somewhere. So post your answers and let's see how well you do. So this is a question about dilation, because obviously they have dilation in every single answer choice over here. Now what's the deal with dilation? So you want to understand this idea very well. This is the original equation, and when you dilate it, the easiest way to think about how much dilation is to look at the y-intercept. So this is your initial and this is your final. So you just take 8, which is your final value, and this is the initial value, the pre-image. You take the ratio of it, and the answer is 2. And this is actually the amount of dilation. But in this problem, the slope never changes. When you dilate, the slope never changes. So the actual dilation would be y is equal to 1 over 3x. The slope would remain the same, and you would only change this 4 to an 8. But in this case, you're actually changing it to 2/3. So therefore, this is not a dilation of this. So clearly, it's not a dilation because the slopes are different. In other words, when the slopes are different, so they are no longer parallel, the second line is kind of like having a higher slope of 2/3, while the original line has a slope of 1/3. So therefore, line Q is not the image because the lines are not parallel. In other words, the slopes are different. Now I got an easy question for you. What happens to this line if the dilation is 10? So post your answers in the comments. What happens if the dilation is 10? Remember, when the dilation is 10, only the y-intercept changes by a certain amount, and the x and the slope doesn't change. So post your answers in the comments with this concept, and then let's move on. To solve a sequence of transformations, you only want to follow this important strategy. You always first want to check if the image is a reflection. Then you want to check if it's not a reflection, is it a rotation? And then only after you do these two things, you want to finally do the transformation, the translation part. So you've got always either a reflection or rotation, and then the translation part. So this is the first step. This is usually the second step. So let's see if it's reflected. Now, what is the meaning of reflection? Let's think about it for a quick second. So think about this letter Q. When it's reflected along this side, it's going to look like this, right? It looks reflected. When it's reflected to the y-axis or about the x-axis, it's going to look like this. It's kind of like water reflection, and this is a mirror reflection, the earlier one. So does this look like it's a reflection? Does this look like it's a reflection of this side? Yes, it does. So kind of let's reflect this up over here across the y-axis. So let's try to reflect this. This point goes here. In other words, if this is to the left, you just mark the same point but to the right by the same units. Since this is to the left by 1, you just move this to the right by 1 unit over here. This is to the left by 2 units, so you're going to move it to the right by 2 units. And then over here, how much is this? 1, 2, 3, 4, 5. So 5 units to the left, so you want 1, 2, 3, 4, 5. So this part over here. And so therefore, this reflection this is a reflection over the y-axis. Right? This is a reflection over the y-axis. That's the first step. Now, do you see how much translation you need to do? So out of these two, reflection is correct and rotation is incorrect. Now you go to the step 2 and see how much is moved up. Obviously, you can take any point over here. You can take a look at this point. It's moving 1, 2, 3, 4, 5. So it's moving up by 5 units. Is it moving to the left or right? No. So it's a reflection over the y-axis, and then after that a translation of how many units? 1, 2, 3, 4, 5. 5 units up. And that's your answer. So these two combined pieces will give you full points on your test. All right, now it's your turn. Now this triangle DOG is being transformed to this triangle over here. Now your task is to find out, is it a reflection or rotation? If it is a reflection, is it a reflection over the y-axis or over the x-axis? And then after that, once you are able to reflect it, then you try to translate it. So how much of a reflection is this and over which axis? And then translation, once you reflected it, what is the translation after this? So post your comments. Let's see if you can solve this. So you've got this angle, this triangle over here, ABC, and they're saying it becomes A prime, B prime, C prime over here. This is the image. This is the original triangle. So now how do you solve this? Remember what we've talked about earlier is you always first want to find out, is it a reflection or is it a rotation? So in this case, it doesn't look like a reflection. It's probably a rotation. Now, how do you find it? You're seeing a lot of 180 degrees answers here. So the first thing you want to think about is you connect the A prime over here with the A, just directly connect it like this. Then you take this B prime and then directly connect it like this. and then this C prime, you connect it like this over here. So where do all of these lines intersect? It's all intersecting at this point. And so therefore, when such a situation occurs, it means it's 180 degrees rotation. It's 180 degrees rotation. About which point? Of course, about this point, which is 1 comma 1. And so the answer is 180 degrees over 1 comma 1, which makes choice 3 as the correct answer. Now here's my question for you. In case you have a point here, it's 2 comma negative 3. If you were to rotate this and move it here, what would be this new point over here? What would be the image of this point? What would be the coordinates of this point over here? So post your answers in the comments. If you have 2 comma negative 3 and it's the same way, it's rotated about the same point, what would be the coordinates of this new point if it's rotated by 180 degrees? So I'll wait for your answers. All right, in this transformation question, they're asking which of these do not preserve the distance. In other words, they might be reflected or rotated or translated, but they're not dilated. So they're asking which of these is giving a dilation. In other words, if you have this line, it could get dilated like this, or it could get even shrunk. It could get expanded or it could get shrunk. So that's not allowed. That's what they're asking. And how do you find the answer? Any place where you have a number, not a sign, a number in front of x or y, then it's a dilation. In other words, it's the transformation is not preserved. The distance is not preserved during the transformation. So where exactly do you have a number in front of x or y? That's going to be your answer. So I'll leave with you to find the answer in one of these places where you have a number which is different than 1, something else, and then post your answers to tell me what you think is the correct answer and how much is the dilation in that case. So post your answers and I'll be waiting. So this is a sequence of rigid motions and it's relatively complicated. So I'm going to give you the answer. The answer is first you want to rotate it 90 degrees counterclockwise. So what's the main idea here when you rotate something counterclockwise? So let's look at this point here. This is 3 and 1. So you've got 3 and negative 1. Now when you rotate something here, clearly counterclockwise means in this direction. So it's going to go from the fourth quadrant to the first quadrant. But how do you solve this? You simply flip the order here. So 3 negative 1 becomes 1 3, and you ignore the sign. So it's positive because it's in this quadrant. So let's just quickly draw 1 3 here like so. Now you look at this point. This point is 1 comma negative 5. Again, you flip it. It becomes 5 1. So let's just plot it over here. 5 1. Simple as that. And then this point here is 1 2 3 4 5 6 6 comma negative 3. So you've got 6 comma negative 3 here. You just flip it, it becomes 3 comma 6. So you've got 3 comma 6, which is 1 2 3, and then 6 up, 1 2 3 and 1 2 3 here. And these are the rotated points of this particular triangle by 90 degrees. So let's just connect them here like this. So when you connect it, you're going to get this triangle. Now what are they saying? You rotated it, done. Is it reflected over the y-axis, which means how much ever you're here to the right, you just simply mark a point here to the left. Since you're 1 unit to the right, you just mark 1 unit to the left. You're 3 units to the right, mark 3 units to the left. You're 5 units to the right, you mark 5 units to the left. Or you can also do this way. You can just put a negative in front of them over here, and that's going to give you these values. Either way, you've got this actual answer, and so therefore this part gives you the correct answer. It gives you this image after this transformation of 90 degrees counterclockwise rotation and then a reflection, and so therefore 3 is the correct answer. Now that I've told you this answer, you can do one more thing. You can rotate it counterclockwise in this direction and then reflect it. So if possible, let me know what are the units of this triangle when you rotate it clockwise, and then when you reflect it, you're guaranteed to get this answer. So let me know what are the coordinates when you rotate it by 90 degrees in the clockwise direction. So that's the main idea. What's the answer? I'll wait for your answer. So they're saying a line is dilated by a scale factor of 1/3, and then what's going to happen? What is the correct choice here? I'm going to give you a hint on how to solve this problem, and then you will be able to solve it yourself. Let's take an example. Y is equal to 6x plus 12, and this is the original line. When it's dilated by a scale factor of 1/3, what happens is this part remains the same. You never change it. The slope is always the same, and only this part is multiplied by the scale factor. So plus 12 times 1/3 over here, like this. 12 times 1/3. So the answer is the new dilated line is 6x plus 12 over 3, which is 4. So that's the new line. This is the original line. So having said that, now it's your turn to actually find the answer to this and post your answers in the comments. Let's see if you totally understood this problem. Very important question to solve. This is a very easy problem. You're given this triangle here. The coordinates are over here, and then I'm just drawn this figure for illustration. You don't even actually need to plot it on the coordinate plane. They are saying this triangle is translated by 5 units to the right, which means every single coordinate here, every single x coordinate, you just simply add a 5 to it, and then you've got 5 units down, which means every single y coordinate, because down or up means the y coordinate, right? You subtract the 5 from it. So let's do it real quick. You've got the actual coordinate a, which is -2, 4. Now what you want to do is you add a 5 here and you subtract 5. So what do you do? -2 plus 5 gives you a +3. So this becomes +3, and here you've got a -5. So 4 minus 5, which gives you a -1. This is the coordinate of a prime. Then let's work on b over here. You've got -7 comma -1. You simply have to do the same thing. You add 5 here. -7 plus 5 gives you a -2, and here you subtract 5 from -1, you get -6, and this is b prime over here. Finally, you've got c over here, which is -3 comma -3. Again, you add a 5 here, subtract a 5 here. So what do you get? -3 plus 5 gives you a +2, and -3 minus 5 gives you a -8, and this is c prime. So these are the answers to this question. Now you try to solve a new problem here. This is the original triangle, but now it's actually translated. It's translated 6 units to the left. So remember, right means plus, 6 means minus, and then 5 units up. 6 units left, 5 units up. What happens to the a? What is the a prime? What is the b prime? And what is the c prime? Remember, this is really going to help you improve your score and get focused on this particular topic very much. So I wish you the best, and I look forward to your comments on this question.